So what we're gonna discuss today is we'll be seeing calculations of these cells. We'll be seeing the properties of electrode potential. We'll be seeing the determination of electrode potential. We'll be seeing the calculation of standard electrode potential. So these are the four things that we're gonna discuss today. Okay. So once read this question. So what he is asking? So see here, the Gibbs energy for the decomposition of Al2O3 at 500 degrees is as follows. 2/3 of Al2O3 is reacting and it's forming LO2. So he is given the reaction. Delta Rg, he also given the Gibbs energy and he is given the temperature. The potential difference needed for the electrolytic reduction of Al2O3 at 500 degrees is at least. Okay. So remember, whenever you are reading the question, just make sure what is the actionable information that you have. Okay, so whenever a question you are reading, what is the data that is given, and in that data, what you can use, and can you relate any formula? Remember these things. Okay, so here, what are all given? He is given a reaction, and he is given the Gibbs energy value, and he is asking us to find out the potential difference. That means he is asking us to find out the V value. Okay, so we know the Gibbs energy formula. And when I am reading this, when you mention the Gibbs energy, the formula that I get is delta G is equals to minus NFE. Yes or no? Yes or no? Here, what I need to find out, I need to find out the E value. That is what I need to find out. Okay, so here the delta G is given minus N. I don't know what is N value here. I need to find out by using this reaction. And I know F value. So if I find the N value, and I know the F value, and I know the delta G value, so I can find out the E value. Yes or no? Understood? Yes, sir. Whatever the theory that's given 500 degrees Celsius, blah, 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 that's all not needed. Here, he repeated 500 to just confuse you. But here, whatever the information, the main principal information is this reaction, the Gibbs energy, and what is the question he is asking. What he is asking us to find out? The potential difference. These are the only three things. What is that? First one is the reaction. This is 1, 2, and what he is asking 3. These are the 3 important things that I need to notice from this question. That's it. Whatever the other thing is there, just leave it. So remember, sometimes the question will be so lengthy and so much of over information that we don't need at all. So okay, just come back to here. So what is the chemical reaction is given? Al2O3, that's giving Al plus O2. So what I need to find? I need to find out N by using this reaction. And what is N? What is N?
Moles of electron.
Yeah, it's a moles of electrons that are involved during the reduction or during the oxidation. Yes or no?
Yes, sir.
So yes, if I see this reaction, whatever the initial reaction that's given here, 2/3 Al2O3, that's breaking down into Al plus O2. Okay, and the Gibbs energy is 96. So from this reaction, if I want to write down the reduction and oxidation, I need to consider 2 things. One is Al2O3. In this Al2O3, which one is reducing, which one is oxidizing, I need to understand. Okay, so which one usually reduce and which one will oxidize? Can someone say? Who wants to donate the electrons?
Sir, O will oxidize.
O always oxidize. Aluminium wants to reduce. Yes or no?
Yes.
So here, for suppose if let me write down the reaction. Okay. So if you see that ionic reaction, it is given as 2/3 of Al2O3. It is giving rise to Al plus O2. And the Gibbs energy, how much it's given? Plus 966 kilojoules per mole. This is what the information is given. So I'll just break down this reaction. So if you see here, when I break down this reaction, here I need to find out, this is the redox reaction. Okay, so in this redox reaction, I need to see what is the reduction and what is the oxidation. These are the 2 things I need to know. So let's see what is the reduction. First, suppose aluminum is there, Al, which is ionic state plus 3. So this Al plus 3, it will gain 3 electrons so that it will turn out to be Al. Yes or no? And you see here, on the right side, I have O2. So if I see 2O2 minus, it will turn out to be O2 plus 4E minus. So this is the oxidation. You may get, sir, how do I know whether it's a plus 3 and 4 electrons? How do I get to know that? Just you should know this. For every atom, there will be certain charges will be present. For suppose you know oxygen is -2 charge. Yes or no? Yes or no? For suppose you know sodium, it's
Yes,
plus
sir.
1. Chlorine, it is -1. Fluorine, it is -1. If you don't know aluminum, at least you know oxygen, it's -2. So it is Al2O3. That means 3 oxygens. So they are making -6 electrons. So that those -6 electrons should be balanced by 2 aluminum. So what will be the charge of the aluminum? Obviously, 3 into 2. Yes or no? So it will be +3 charge. You understood?
Yes, sir.
If you don't
Yes,
know
sir.
aluminum, at least you know the oxidation state of oxygen, the ionic state. What will be the charge on the oxygen? You know, it's -2. And there are 3 oxygens are there, which will be balanced by the 2 aluminum. So here -2 into 3 oxygens, I'll get -6. So this -6 should be balanced by the aluminum. See, this is not lengthy process. If you don't know, I'm just telling it, okay? So this is how you will be arranging the reduction and oxidation. Okay. But if you see here, this is not according to my, I mean, these are 3 electrons are okay, fine. But how can I balance number of electrons based on this reaction? So for that, I need to multiply this equation by 4 and this equation by 2. Not 2, sorry, by 3. Okay. So see here, if I do, how much I'll get? 4. I'll be getting 4Al plus 3. 4 3s are 12. So 12 electrons and 4Al.
So why did we take 4 and 3? So I didn't understand.
I'll tell you, Banu. Let me write fully. I'll tell. Okay. And see here, this will be 6, 3 2s are 6. 6 oxygen. This oxygen will give 3O2, 4 3s 12. 12 electrons. Okay. Now the question is, the Banu asked why we are multiplying with 4 and 3. So if you see here, what is the value? It's a 2/3 of Al2O3. Yes or no?
Yes, sir.
So
Yes,
if you see here, how many aluminiums are present here? The upper value, see. Leave about the denominator. See about the upper value. How many aluminiums are present?
for 4, sir.
4 aluminium are there. How many oxygens are there?
6.
6 oxygen are there. So if I want, leave about the denominator. If I want to find out the denominator, it will become difficult. So instead, what I'll do, I'll find out the numerator value so that I'll get number of electrons are involved in this reaction, and then I'll divide by the 3 so that the actual number of electrons are there in this. The number of moles of electrons in this reaction are happening. I'll get to know. Understood?
Yes, sir.
So what I'm doing 2Al2O3 and I'm dividing with 3. If I do 2Al2O3, I'll get the number of electrons here and number of moles of electrons here. And I'll divide by 3, I'll get the actual number of moles of electrons involved in this reaction. You understood? So what I need to find out, N. What is N? It's nothing but the number of electrons that are transferring during the reduction or oxidation. Here 3 electrons are reduced. Here the electrons are given by the oxygen. So that I need to know. Do you remember? Yesterday I discussed, so during the oxidation, the electrons are released. Those electrons will be transferred so that they will be reduced. Yes or no? So at some electrode, the oxidation will happen and that will release certain electrons. Those electrons will pass and I'll reach to the place where the reduction is happening. So I need to find out what number of electrons are moving in this. That I'll get to know by this reduction reaction. You understood?
Yes, sir.
Yes or no, or should I explain again? It's okay. Take time, I'll explain again, but make sure you are understanding. Don't hesitate to ask doubts if you don't understand.
So can you explain again, sir?
Okay, fine. What about the others?
Sir, can you explain again?
Yeah, please ask then. Nitya, what about you?
So, can you explain once more?
So tell me, where does the oxidation happens?
So, at the anode.
Where? Oxidation happens at where?
Anode, sir.
It will happen at anode. And reduction will happen at
Cathode.
cathode. Okay. So what happens here? During at the anode, what happens? The electrons will be released. Yes or no?
Yes, sir.
This is the half reaction. Yes or no? Redox reaction means what? It is nothing but the combination of oxidation and reduction. Whatever the electrons are released at the anode, those electrons will be utilized at the cathode. Yes or no?
Yes, sir.
Yes,
So
sir.
what do we call this as? Electron transfer. In order to find out what is the current, I need to know this how many electrons are passing during the redox reaction. I mean, how many electrons are released during the oxidation and how many electrons are consumed during the reduction, I need to know. Yes or no? So here oxidation is giving out the electrons. During the reduction, whatever the electrons are released, it is taken by the reduction. You understood this?
Yes, sir.
Yes, sir.
So this
Yes, sir.
flow of electrons from anode to cathode, that is what the electricity it is producing, the potential it is producing. Yes or no?
Yes, sir.
So in order to find out the Gibbs energy, so that I need to know what is this N value. This N value is nothing but these electrons which are released in the oxidation, which are taken by the reduction. If he is given the normal reaction, I don't need to do any calculations. I can simply use this. But what he is given in the terms of fraction. Understood? If he is just given Al2O3, I can simply write down the oxidation and reduction. But he is given in terms of fraction. So this reaction, I need to find out what is the number of electrons are. The fractional number of electrons I need to find out. So usually the reaction, if you take Al2O3, that will break down to Al plus O2. I'll be getting Al plus 3 electrons, that will convert Al. 2O2 minus, oxygen, 4E minus. Is this part understood, the green part?
Yes, sir.
Yes, sir.
Yes,
So
yes,
what's
sir.
happening in the reduction? What's happening in the oxidation? You understood this part? Sharan?
Yes, sir.
అర్థమైందా లేదా చెప్పు షరణ్ డౌట్ఫుల్ గా చెప్పక
Yes, sir.
సో అల్యూమినియం it is losing out 3 electrons because aluminum has the capability to release 3 electrons. Oxygen, I mean, it can join. Oxygen, it can release 2 electrons. Like that, 2 oxygens are there, so for total 4 electrons. So I wrote this reaction. But E is given 2 by 3 Al2O3. So I need to find out for this reaction, the number of electrons are reduced and oxidized. Okay, so leave about the 3. First, I am taking 2 Al2O3. That means 4 aluminium and 6 oxygen. If I know these number of electrons, and then if I divide by the 3, then I'll get number of electrons oxidized and reduced in this reaction. Is that clear?
Yes, sir.
You understood now?
Yes, sir.
So why I'm multiplying with 4 and why I'm multiplying with 3?
Yes, sir.
So if I add this, I'll get 4Al plus 3 plus 6O2 minus. That will give 4Al plus 3 oxygen. And total number of electrons that are involved here? How many electrons?
12, sir.
So remember,
12.
this is Al2O3. 2Al2O3. Remember. So this 2Al2O3, it is involving total 12 electrons. Yes or no? If 2Al2O3 are involving 12 electrons, then 2 by 3 Al2O3 involves how many electrons? 12 by 3. If I do that, I'll be getting 4 electrons. Is that clear?
Yes, sir.
Yes, sir.
Yes, sir.
So the N factor, that is nothing but the number of electrons for 2Al2O3 is 12. Therefore, the N factor for 2 by 3 Al2O3 should be 12 by 3, that is equals to 4. Is this clear, this point?
Yes, sir.
So
Yes, sir.
for this to find out, I am writing all this. Okay, if you understood that, you can directly come to n factor. Now I know the formula. So I know n. So what is the formula? Delta G is equals to minus NFE. And delta G is given like 966. And what's the is given? Kilojoules per mole. So I can take into 10 power 3 is equals to minus 4 into F value 96,500 into E.
Yes.
Okay, so I can cancel out this and this, right? So this and this can be cancelled out. So if I do that, the final value, if you do, that will be 966 into 10 power 3 by 4 into 96500. Okay, so if you do the total calculation, the value will come out to be 2.5 E. So what's the answer? Option C. Is this clear?
Yes, sir. Yes, sir.
How you are feeling? Is it difficult or easy?
So medium, sir.
Okay.
So could you do one more question?
See, the same question I'll do in a shortcut. I mean, very simplified. So first of all, delta G value is given. Again, I'm doing the same question in a simplest way. Okay, so delta G value is given kilojoule mole inverse. If I'm writing the exam, I'll write. So the coefficient in front of Al2O3, remember, it is 2/3. Concentrate on this. This is the coefficient in front of Al2O3. Okay, now I need to find out the quick way of n factor. So I'll do, first of all, Al2O3. If they go half reactions, I know aluminium, it is +3 charge, so 3 electrons are involved. Oxygen, O2 minus, like that 2 oxygens are there, so 4 electrons are involved. Clear?
Yes, sir.
So aluminium needs 3 electrons, oxygen needs 4 electrons. And if you see here, 2/3 of Al2O3, that's nothing but, so 3 2 6 and 4 3 is 12. Total how many electron? 1 second, guys. Somewhere. Sorry. Here O2 minus is 2 electrons. So if you see here, total 2 aluminium, that is 3 2 6 electrons plus 3 2s are 6 electrons. So total 12 electrons. You divide 2 by 3. So that will come out to be something I did mistake. 1 second, let me think. Just a second, guys. Okay, I'll just tell this again. Somewhere is I did some mistake. I'll tell this again. It's not balancing. Anyways, this long method you understood?
Yes, sir.
Okay,
Yes, sir.
just here this big calculations came because of this fraction. Okay, is this fraction clear or not? Let me know. Otherwise, I'll explain again. The short method I'll tell again. I made some mistake. Okay, this long method is okay.
Yes.
Yes, sir.
What about
Yes,
Mandara,
sir.
Sharon? You guys are not answering.
Yes, sir.
Yes, sir.
Okay, fine. So next one. calculation of E cell. So let's write down the electrode reaction first. So at anode, we know the reaction will happen somewhat like this. So A in solid state, it will convert into AN plus, which is aqueous, plus Ne minus. At cathode, so Bm plus. See, make sure you understand this standard form of reaction very carefully. Okay, you should quickly write it. You should not think about it to write. So this redox reaction, you should write it as quick as possible so that you can deal the questions very easily. So if I write down the Gibbs energy for this, delta R G1, it would be minus NFE A by AN plus. Delta R G2 is equals to minus MFE B M plus by B. Okay, so what's happening here? So this is the oxidation that's occurring at the anode, where the neutral A species is oxidized. It is liberated n number of electrons. It lost n number of electrons. That's why it got n plus and E minus. Okay, for suppose in the previous case, Al plus 3 E minus, like this. Okay, so you can see here, Bm plus Me minus, it will give rise to B. Okay, the same here, the reduction is happening at the cathode, where a metal ion, which is Bm plus, it is reduced by m number of electrons, and now it got the neutral state B. Is this clear?
Yes, sir. Yes, sir.
So how do we find out the E cell? For E cell, in order to find out, what you need to do is multiply the equation 1. For suppose this is the, let's say this is the equation 1. So this is 1, this is 2. Okay, so remember, you multiply the equation 1 with the m value, and you multiply the equation 2 with the n value. You understood this? Whatever the equation 1 is there, where it lost the n number of electrons, that you need to multiply with m electrons. The same way, whatever this equation is there, it should be multiplied with n. Is this clear? So see here, multiply equation 1. I'll tell you, once we done the complete thing, then you will understand what is this. So multiply equation 1 by m and multiply equation 2 by n. Then you add both the equation 1 and 2. See, whatever that we did in the previous thing, that we are doing again. This one. The same thing we did here. Okay. I mean, similar kind of thing we did here. Okay. So see here, multiply equation 1 by m, multiply equation 2 by n, and then add the equations. And add the equations. Is this clear up to here? Any doubts?
No, sir.
No, sir.
No, sir. No, sir.
No, sir means you didn't understand anything. Or
No doubt.
No doubt, sir.
so see here, this is the corresponding Gibbs free energy. This Gibbs free energy for the anode, this Gibbs free energy for the cathode. Remember this, okay? Corresponding Gibbs free energy change. Okay, so by the anode, what is the Gibbs free energy that is changed? By the cathode, I mean, at the cathode, whatever the reaction is happening, off reaction, by that, how much amount of Gibbs free energy is changed? So this is the value. This is the value that is due to the change happening by the chemical reaction at the anode. This is the Gibbs free energy that is changed by the chemical reaction that is happened at the cathode. Okay, if you remember yesterday I told you, till when the circuit is off, when the no electrons are flowing, the Gibbs free is normal. But when the chemical reaction is happening, the Gibbs free will be influenced. It will be changed. So this is the change that you see at the anode. This is the change that you see at the cathode. Is that clear? At anode, you will be given by the N into Fe. At the cathode, you will be given minus M Fe. Because we know this is the M means the number of electrons. Here N means the number of electrons involved in this. Is that clear? So what is this? Oxidation or reduction?
Reduction.
Reductions.
Are you sure? What is this, Nitya? Oxidation or
Sir,
reduction?
anode is oxidation, sir.
Guys, please see here what happening here. Normal state is there, and after reaction it lost the electrons. You can see here. What is this? This is oxidation, and here the electrons are added. Now it become B. What is this? Reduction. This is reduction, because you are giving the electrons to a compound so that the compound is reduced. What's happening here? You are taking out the electrons from the compound, so it got the ionized positive charge, and number of electrons are released. So this is oxidation. Please think before you answer. Understood? Is this clear up to here? Can I move next?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now what I need to do? I need to add the entire thing. Okay. So when I add, the cell reaction will show like this. So what we did? We multiplied the anode equation by M. We multiplied the cathode equation by N to balance the electrons. Okay. Now we are adding the resulting equation. So the cell reaction, it is M A plus N B M plus M A N plus aqueous plus N B solid. Is that clear? What I did, the same thing. So here I multiplied this M. Let's say this is first one. This is second one. I multiplied this by N. So M into A, you can see here MA. And you can see here N into B and B M plus. Now I added both. So when I added MA plus NB M plus, so that is what I got my left side. The same thing I did in the right side, which is the Gibbs energy here, delta. Let's say this is delta Rg. This is the third Gibbs free energy. So let's say this is delta Rg1 for this reaction, the Gibbs energy, delta Rg2 for this reaction, the Gibbs energy, and for this entire equation, this is the Gibbs free energy. So I can say now this Gibbs free energy is equals to sum of these two. Yes or no? What I did here, I added this and this, I added this and this. So I can also add this and this will give delta Rg3. Yes or no?
Yes.
You understood?
Yes, sir.
So I'm
Yes, sir.
so delta Rg3 is equals to M delta Rg1 plus N delta Rg2. This is the final equation. So from this, once again I'm explaining, please listen carefully. So what I am doing here, okay, first suppose you take, I'm trying to calculate the calculations of E cell. Okay, so what I am doing here, first I need to balance. This is the reaction that's happening at the anode. This is the reaction that is happening at the cathode. And if you see the number of electrons that are released in the anode, it is different. I denoted with N. The number of electrons that are released at the cathode, it is M. Because these electrons are different. For suppose if you say here 2 electrons, here 3 electrons, the number of electrons are different here. But if I want to find out the overall cell potential, in order to find out the overall cell potential, the number of electrons here and here should be equal. For that to balance, what I am doing here, so number of electrons that are released at the anode, I am multiplying for the cathode. And number of electrons released at the cathode, I am multiplying with the anode. So that, and I'm finally adding all the electrons, so that I'll get the overall cell potential. This I'm doing to balance. Is that clear? Why I'm multiplying with M? To balance this equation. Why I'm multiplying the N? To balance with this equation. So in order to balance both the anode and cathode, because both are redox reaction together, this is off reaction, this is another off reaction. In order to balance both the off reactions and make them neutral, I'm multiplying each other with M and N. Is that clear? Any doubts?
Yes, sir.
Yes, sir. So we should first multiply and then add the equation, sir.
I mean, Banu, if it's given, for suppose if you see here 3 electrons are given, here 4 electrons are given. In order to balance that, if you see here, this was multiplied 4, this was multiplied with 3. You understood?
Yes, sir.
That's what we are doing here. That's what I said. So whatever the previous one we did, I'm telling the same thing here, but in more
Okay,
detailed
sir.
way. Clear?
Yeah.
Understood, guys? Any doubts? See, the same thing we did here. See here, 3 electrons, 4 electrons. In order to balance 4 into 3. But I told you in this way to, because I didn't explain this at the time, so I told you in this way. But now you understood. చెప్పండి రా స్వామి అర్థమైందా అర్థం కాలేదా శ్రీకర్
Yes, sir.
here at that time I didn't tell you those equations, so I told you 2 by 3 Al2O3 here Al2O3 I need to balance this way, so I multiplied with 4 and multiplied with 3 because here 3 electrons are there, so you multiply the reduction here into 3, here 4 electrons are there, so multiply here with 4. That's what I did here. Now what I did at last, I added both the two equations. Yes or no? So you see here 4Al3 plus CO2 minus plus 4Al plus 3O2. Here also I did the same thing. I added both. And I got the final reaction. So this is the Gibbs free energy for the off reaction that happened at the anode. This is the Gibbs free energy for the off reaction that is happened at the cathode. Now, this is the total Gibbs free energy of the overall reaction. So this total Gibbs free energy is equals to sum of Gibbs free energy that happened at cathode plus Gibbs free energy that happened at anode. Is that clear?
Yes, sir.
Okay, so why we are balancing? Remember, number of electrons transferred should be equal in both off reactions. Okay, if you are having, for suppose there are two reactions are there, A and B. Both are half of reactions. In this 2 are there, in this 3 are there. In order to balance both, what I did, I multiplied this with 3, I multiplied this with 2. So overall, I got 6 electrons. The same thing I did here. So, okay, anyways, I'll write for you if you forget. So here, balancing, this will ensure that number of electrons transferred is equal, should be equal or is equal in both off reactions. That's one thing. Now, if you see here, the overall Gibbs free energy change represents the complete reaction. This is the complete reaction and this is the overall Gibbs free energy. And if you see the cell potential here, okay, if you see the final calculation, the overall cell potential, whatever the overall Gibbs free energy is there, it is nothing but the combination of both the off reactions. So this plus this. So you can say this plus this. Clear? That's overall Gibbs free energy or overall cell potential. Or you can say the overall cell potential is equal to sum of both off reactions or sum of both coupled reactions. So tell me honestly, till now, who understood without any doubts? And who are feeling sleepy, who are want to end the class now?
So I understood it here, sir, but I have to watch the video again so that I can understand fully again.
Okay. What about the others?
Sir, even I understood.
Understood, sir.
Understood, sir.
Who understood without doubt so far?
Understood, sir.
Understood, sir.
Yes, sir.
Okay, good. So finally, I can conclude that change in Gibbs free energy delta Rg3 is equals to sum of individual free energies changes. Or you can say M delta R G1 plus N delta R G2. Let me write M N. Understood? This is the total delta R G3 you see. So see here, delta R G3 is equals to M delta R G1 plus N delta R G2. You can understand, right? M means the number of electrons released here. N means the number of electrons released here because we multiplied oppositely. Okay, so for delta R G3, it will be value Nm because both I'll need to consider. So Nm Fe cell is equals to minus Nm Fe An plus. Let me write down. So minus Nm Fe cell is equals to minus Nm Fe. One is oxidized, so it will be An plus. The other one will be reduced. Nm Fe Bm plus by B. So this is oxidized because A is converting to An plus. Yes or no? For suppose aluminium is converting into aluminium plus 3 E minus. Oxygen O minus 2, it is converting into O plus 2E is converting into oxygen. That is how it is. An plus means this is oxidized. Bm plus to B means it is reduced. Okay. So I can finally give E cell is equals to E A by An plus E by B M plus by B. This is the final equation. So see here, what is the M and N here? The stoichiometric coefficient. Okay, so M is, we saw here, and what is N is? Okay, M is nothing but the number of electrons that are reduced at the cathode, and means the number of electrons that are oxidized at the anode. Okay, and F means we know it's a Faraday's constant. Okay, so this is the overall cell potential. Okay, when individual electrode potentials are given. So this is the electrode potential, this is the another electrode potential. This is the oxidation happen, this is the reduction happen. Or you can say this is the electrode potential of the anode, this is the electrode potential of the cathode. So together this one. Clear? Understood
Yes,
this?
sir.
Yes, sir.
Yes, sir.
Okay. So see here. See here, minus and minus, they are going away. So you got the positive. Don't think like how it was suddenly turned into positive. So when the reduction potentials of both electrodes are considered, then you can say E cell is equals to reduction potential at cathode minus reduction potential of anode. You can say here also of. So reduction potential of cathode minus reduction potential of anode. So you can find, you can say this as E cell is equals to E red minus E red. This is anode, this is cathode, this is anode. Okay, is that clear? What is meaning of red? The reductional potential. Clear?
Yes, sir.
Yes, sir.
So what is E cell? Can someone say what is E cell? We are talking E cell, E cell, E cell. What is that? It is nothing but the cell potential. Okay. So this cell potential, it will be determined by the difference between the reduction potentials of the two electrodes. That is happened at the cathode and that is happened at the anode. At the cathode, the electrodes were reductional, they were reducing. At the anode, the cells were oxidizing. Okay, and remember what is meaning of E red? It's nothing but the standard reduction potential, if you confuse. So E red means standard reduction potential of electrode. I'm writing electrode. It could be of cathode, of anode. You can write that. Okay. So with this, you can say it provides the overall voltage of the electrochemical cell. And remember, if the E cell is positive, then it will indicate spontaneous reaction. If Gibbs free is positive, it will be non-spontaneous reaction. But if the E cell is positive, that means it will be spontaneous reaction. Remember, so positive E cell indicates spontaneous reaction. Negative E cell indicates non-spontaneous reaction. So when can it will be positive E cell? When the large difference you will be seeing between the cathode and the anode. Okay, so the larger the difference for the reduction potential of the cathode and the larger the reduction of the potential of the anode, then you will be seeing the greater cell voltage. That means you can say the reduction potential of cathode should be too high and the reduction potential of anode should be too less. So that this will be positive charge, this will be positive value, this will be negative value, and you subtract positive value with the least negative value, you will get major difference. Understood this? So write down this, just one more thing. So you can write here, larger the difference between reduction potentials of the electrodes, greater the voltage. Clear? Any doubts?
No, sir.
No, sir.
Okay. So here, the difference in electrode potential of the two half cell reaction, that's oxidation half cell and the reduction half cell, that is known as the EMF of the cell, or you can say the cell potential. Clear? So tell me, how do you calculate this? Come on guys, tell me. What is the value? Okay, shall I teach? Chappanra, Norlippanra.
Yes,
Answer
sir.
guys.
Teach, sir.
Okay, see.
So,
Yeah, Banu.
no, sir, I was studying and trying.
So see here. So consider the following E naught values. So E naught values are given. Okay. So under standard condition, the potential for the reaction is okay. Fine. So what we need to find out here? Here we need to find out the standard cell potential for the entire redox reaction. So he is given the oxidation. So what is this? Oxidation or reduction?
Sir, it will be 0.91, sir.
Yeah, Banu. It is 0.91. See, you need to understand which one is at cathode, which one is at anode. First of all, this is the overall reaction. SN2Fe plus, it was converting into 2Fe plus 2 and SN plus 2. Okay, so this is the overall reaction. So the redox reaction is happening between the SN and the Fe plus 2. So if you see here, at cathode, let me write here. So reduction potential at cathode, it would be Fe plus 3 plus E minus. See, you don't need to write all this in the exam. You can directly write the formula and put the value. But in order to understand what is the reaction happening at anode and cathode, I'm writing. So this is the reduction potential of cathode. Next one. Reduction potential at anode. The reaction taking place at there is Sn plus 2 plus 2E minus, it is Sn. So this is the reaction is happening at the anode. So what is the reduction potential? That's at cathode. It is given as Fe plus E. So it is given as how much? 0.74. So this will be 0.77 V. And this will be minus 0.14 V. And what is the formula? We know the overall reduction potential or overall redox reaction potential is equals to sum of reduction plus oxidation. So E naught reduction that's happening at the cathode plus sum of reduction that's happening at the anode. Yes or no? 1 second, guys. So cathode minus anode. Okay. Yeah. So this will be how much? 0.77 minus 0.14. That would be 0.91 V volts. So what's the answer? Option B. Is this clear? Any doubts? So remember always at cathode, the reduction will happen. At anode, oxidation will happen. Clear?
Sir,
Yeah.
Yes, sir.
sir, in the reduction potential, like there should be two electrons to balance the equations. No? So shouldn't 0.77 be multiplied by 2?
No, will not do. Because here already the entire reaction reduction potential has given like a data. See here, it's given like this. E naught value, he directly given the value. If he is not given the value, then we need to do that. But he himself given the value, even though the reaction is not balanced, but he has given. And we know the direct formula, sum of these two. So I added.
Okay.
Understood?
Yes, sir.
Yeah. So properties of electrode potential. So you can see here, electrode potential depends on concentration of solution, nature of metal, nature of electrolyte we are using, and it also depends on pressure and temperature conditions. Okay. And electrode potential and cell potential are intensive properties, and they do not depend on amount of solution, thickness of metal. What is meaning of intensive properties? Remember, if something they say intensive and extensive properties, intensive properties means value remains constant. It will not change. It will not be influenced regardless of the change in parameter, regardless of physical parameter. Okay. You can say like, for suppose the system size or amount of material, if it is changed, it doesn't depend. Okay, so those are intensive. The opposite is extensive. Extensive means the value changes based on the change in the physical parameters. Like if you change the amount of material, it will change. If you change the size, it will change. You understood? So it's a intensive property. It doesn't depend on how much amount of solution you add or how much thickness of metal you take. For suppose you see here, so stoichiometric variation in electrochemical cell reaction. For suppose if you see here, A2 plus 2E minus, it's A. 2A plus 2 plus 4E minus, it's a 2A. But if you see E is equals to X volt, E is equals to X volt. What you understood here? Can you guess what you understood here? For suppose if you see the first reaction, what's this? It's the off reaction, right? So what's happening here? There is an aqueous metal is there. That aqueous metal, it is receiving 2 electrons and it was converting into A, the solid metal. So what is this reaction? Oxidation or reduction? What is this reaction, guys? You are taking 2 electrons and you become a neutral. What is that called? Taking of
reduction.
electrons, addition of electrons. It is a reduction.
The reduction.
And what's this reaction? This is also reduction reaction. But here, what you did, you doubled the number. For suppose here A plus 2 is there, you increase it to 2A plus 2. Here 2 electrons are there, it was increased to 4 electrons. Yes or no? So here simply you multiplied the factor by 2. But the potential is changed here. Does the potential change between the two? Come on guys, tell me here the potential is changed. Still it remained the X volt and X volt. That means it was not changed. Yes or no? So the potential, the E value, it remains unchanged despite you doubling the stoichiometric ratios or stoichiometric coefficient. Even you increase it this A to 2A, 2 electrons to 4 electrons, A to 2A, but still the potential E remains constant. It was not changed. Can I call this as an intensive property? Even though the number of electrons transferred were double, the number of reactants were double, the number of products were double, but still the nature was remained same. The volt were the potential, the cell potential is still same. So can I say the cell potential is intensive? What is intensive? The value remains constant regardless of change in the physical parameter. So can I say the potential is also intensive?